Welcome to Rawmachines, a journey to discover the most impressive processes around the world. In today's episode, we will follow the marvelous rebirth journey of wood, from the deep forest to the mill, from raw material to the finished product. Our destination is Kiln's Lumber Products, a legendary sawmill in the southern United States, where technology and nature harmonize in every movement. Let's begin. As the sun just crests the forest, convoys of log trucks head straight for the mill gate. Each log is an individual, different in age, species, and grain, but all are the main characters in this mechanical rebirth journey. Each truckload of wood is weighed by an electronic system to accurately determine its weight. A single shipment can weigh up to 26 tons, equivalent to 15 adult elephants. After being unloaded by the hydraulic crane, the logs are placed onto the log deck, the starting platform for their journey. Here, the wood is moved by the conveyor to the automatic debarker. Amidst the screech of the steel rollers, the rough bark is stripped away, revealing the bright pale wood underneath, pure and raw. The bark is not discarded. It is ground down, and then becomes biomass, supplying energy to the mill itself. A small, closed, no-waste cycle. Once the log is cleaned, a 3D laser scanner begins to scan its entire shape, creating a digital model accurate to the millimeter. The artificial intelligence system analyzes this model to determine the optimal cutting direction, the way to yield the most, best-looking, strongest wood from every fiber. In the blinking blue light of the laser, the log is as if its soul is being illuminated, and from there, its own future is shaped. After being debarked, the wood can follow two paths. Larger logs, with diameters up to 1 meter, are transferred to the head rig, head saw. This machine is responsible for the initial separation of large logs into thick boards, called slabs, and solid central blocks, called cants. The head rig is guided by a multi-point laser scanning system, but instead of just calculating speed, it calculates the cutting strategy, how to ensure each cut both creates maximum value and preserves the internal grain structure of the wood. As for the smaller logs that do not require complex separation, they are transferred to the single-pass saw system. From one end to the other, the log takes only a few seconds to completely change its form. When it exits the machine, it has become a bundle of parallel boards, perfectly uniform, bright in color, with clear grain visible. Here, simplicity is the peak of efficiency. There is no waste, no hesitation, only technology and a clear objective, converting raw material into a precisely shaped product. After each cut, the slabs are transferred to a secondary line for further resawing, splitting them into thinner boards, while the solid central core, cant, is sent to the curved gang saw, where naturally curved wood is processed to maximize the utilization of every fiber. The curved gang saw is a marvel of modern engineering, designed to cut along the natural curvature of the log, rather than forcing it into an artificial straight line. A sensor system scans the log's entire shape, creating a precise three-dimensional map simulating every curve. This data is transmitted to the central control unit, where a series of algorithms calculate the optimal sawing path, ensuring that each cut both aligns perfectly with the wood grain and yields the highest production volume. As the process begins, the log moves through a set of rollers that can rotate and tilt flexibly at every slight angle. The saw blades, instead of being fixed, are mounted on an axle system capable of bending and leaning according to the predetermined scanned path. At a speed of several thousand revolutions per minute, the thin, ribbon-like steel blades glide through the log, gently yet decisively, leaving a smooth, unbroken, and unsplintered cut surface. The feeling is almost surreal, as if steel is reading the language of wood. The result is a 10–15% increase in wood recovery compared to traditional straight sawing. After the initial sawing stage, the wood boards still retain a hint of the forest's wildness, curved edges, rough ends, and coarse surfaces. Now they need to be refined to become industry-standard products. On the conveyor, the boards move toward the edger area. Here, laser sensors scan the two edges of the board, determining which part is useful wood and which part needs to be removed. In a flash, steel saw blades descend, slicing through the board edges at incredible speed. In just one pass, the two edges of the wood are cleanly trimmed, straight and parallel. From the edger, the boards continue sliding to the trimmer cross-cutting station. This system consists of dozens of saw blades positioned 2 feet apart. As the board moves through, only the necessary blades are activated, trimming precisely to the standard size. The entire workshop operates like one massive synchronized machine. At every stopping point, people are silently observing, checking every cut, listening for every change in the machine's sound. They don't just operate the machines, they care for the wood, ensuring that every board leaving the line is the crystallization of technology and respect for the material. After being perfectly cut and trimmed, the boards continue sliding on the steel conveyor to the finishing and drying area. This stage determines the durability, color, and ultimate utility value of each board. The sorter system operates like a tireless army. Each board is lifted, rotated, and gently dropped into the bin corresponding to its size, length, and thickness. When sufficient quantity is reached, the stacker machine begins its work. Mechanical arms pick up each board and place it atop the others, interspersed with thin wooden strips known as stickers. These serve to allow even air circulation during drying. This is a rare, peaceful moment on the production line. After the sounds of cutting and screeching, everything is now just the deep, steady sound of the air compressor, like a long breath before entering the kiln. The drying process is not simply about getting the wood dry. It is a delicate refinement, requiring a balance between heat and time. If the heat is too high, the wood will crack. If it is too low, it will not be dry enough to be stable. Therefore, every kiln is fitted with sensors that continuously measure the moisture content, updating data every few minutes. When the process concludes, the doors open again. The steam dissipates, revealing boards that are evenly dried, lighter, harder, and possess a natural warm yellow color. They are no longer the damp material of the forest. They are now engineered lumber, ready for the construction and furniture industries. The wood enters the final stage, finishing and inspection. The first step is planing. Here, high-speed rotating blades smooth the surface, creating a seamless feel and uniform thickness. Once the surface is finished, the wood passes through the grading station. Part of the work is handled by experienced craftsmen, who can spot hidden cracks or small knots just with a glance. The rest is performed by industrial cameras and machine learning algorithms, identifying over 70 different types of defects. When the wood meets the standard, the grade stamp is printed onto the board, a small symbol that holds the entire honor of the mill, certifying that this board is fit to enter human life. When everything is complete, each wood consignment is bundled and shipped. Steel straps are tightened around the wood stacks, and identification tags and the mill's logo are printed onto the surface. Forklifts carry them out to the loading area, where the natural sunlight makes the wood gleam with a honey-like color. Some bundles are loaded onto trucks to serve the domestic market. Others are moved to the port, awaiting export to distant regions. From here, the wood's new journey begins. Some boards will become house frames, others flooring, and some will be carved, painted, or sculpted in furniture workshops. And in every one of these products, the essence of this mill remains. where forest trees are reborn through technology, where nature and machinery meet in mutual respect. The drying and finishing stage concludes not with the sound of machines, but with silence. In that silence, one understands that the wood is ready to live another life, longer, more durable, and perhaps even more beautiful than the original tree itself. From theory to reality, the journey of wood becomes clearest at Kiln's Lumber Products, one of the most advanced and oldest sawmills in the southern United States. Kiln's Lumber began as a small planing mill in the 1930s. Back then, there were only a few workers, a bandsaw, and some canvas to shield them from the weather. Over nearly a century, this family business has grown into a massive production system, capable of processing millions of board feet of lumber annually. Yet, amidst the automated conveyor belts and touchscreens, the spirit of the old mill remains, the spirit of respect for wood, people, and the forest. The morning at Kiln's begins at the log yard. Thousands of trunks are stacked like giant walls. The strong scent of pine resin permeates the air, and steam rises in the early sun. This is the mill's raw material bank, a plentiful reserve to keep the production line running continuously, regardless of weather or fluctuations from the deep forest. And when the signal from the control center lights up, the crane gently lifts each log onto the log deck, feed floor, where it will be reborn in a new form. The mill's debarker is a gigantic rotating steel cylinder, where logs roll through and are stripped clean of their rough bark. The bark fragments fall onto the conveyor belt below. They are not discarded, but collected for biomass fuel or landscape mulch. Next, the wood passes through the laser merchandiser. This is the point where technology begins to intervene deeply. A network of laser beams scans the log, creating a three-dimensional image of each segment, its length, diameter, curvature, and defects. A central computer processes hundreds of calculations in a split second to determine the optimal wood utilization. If the log meets the perfect size and straightness, it is routed for processing into utility poles or beams. If not, it is cut into standard lumber. Every decision is made instantly, both fast and accurate. Here, artificial intelligence does not replace humans. It amplifies their capabilities. The operator only needs to look at the control panel, where dozens of cutting models are displayed, and select the optimal option suggested by the system. Subsequently, the log is directed to the appropriate sawing line. At Collins Lumber, there are two main lines, each a world unto itself. The first line is the carriage saw line, reserved for enormous logs with large diameters. The wood is secured onto a motorized carriage, after which a laser scans it one last time to determine the optimal cutting path. The first cut sounds, dividing the log into large slabs, thick, heavy, and smelling warmly of wood resin. These slabs will be resawn on a secondary line into boards, while the central core, the thickest and hardest part, is sent to another line for the curve gang saw, curved cutting. This is where machine and human perform together. Workers monitor the cutting direction and adjust the speed, ensuring every cut aligns precisely with the laser map. The result, a wood recovery rate exceeding 90% with almost no waste. The second line is the reducer twin saw line, a more sophisticated system specializing in processing medium and small logs. Here, chip heads plane two sides of the wood before the vertical saw blade splits it, creating two boards with perfectly planed surfaces. The log is then automatically rotated to cut the remaining sides, removing the sideboards, typically 1 to 2 inches thick. The remaining core is then sent to the curved saw gang. Here, flexible, thin saw blades move along the natural curvature of the wood grain, optimizing every inch of the raw material. Column's chief engineer once said, "We don't force the wood straight, we listen to it." And indeed, this system is proof of that philosophy. Technology respecting the laws of nature to maximize yield without breaking the wood fiber structure. From here, the boards are transferred to the edger, edging, and trimmer cross-cutting area. The curved edges are cut flat, and the lengths are standardized. An industrial camera system checks every cut, comparing it against the technical design to ensure each board meets the exact specifications. At every step, people are supervising, not only for safety requirements, but because the craftsman's eye can still see things the machine cannot yet perceive. Once the wood has reached its standardized shape, it is moved to the sorting and stacking area. Here, the automatic sorter line, dozens of meters long, receives them. Each board passes through size and weight sensors to determine its thickness, width, and specific gravity. Based on this information, the system sorts the boards into over 40 different bins. When each bin has a sufficient quantity, the stacker machine starts up. Hydraulic arms lift the boards, stacking them into uniform piles. Between the layers, small wooden strips, stickers, are inserted to create gaps for airflow. This is a seemingly minor detail, but it is vital. Without stickers, the wood will not dry evenly, leading to future warping and twisting. When completed, the piles of wood, nearly 2 meters high, are pushed by forklifts to the kiln waiting area. Here, hundreds of stacks are neatly arranged, a scene that is both majestic and tranquil. The scent of fresh wood permeates the air, rich and warm. Stack of boards is loaded into a massive industrial dry kiln. The steel doors close, and from that moment, heat, humidity, and pressure begin their dance of physics. The automated control system keeps the temperature between 70 and 90 degrees Celsius, cycling hot air to ensure every board dries evenly, from the core to the edges. Electronic sensors are inserted deep into the wood, tracking internal moisture hour by hour. The readings appear on a central monitor, forming wave-like graphs, almost like a heartbeat. When the curve approaches the 15% mark, the engineers know the wood has reached perfect equilibrium. During the process, water inside the wood fibers slowly evaporates, leaving behind a more stable, lighter, and stronger structure. Each species has its own drying cycle. Pine takes about 48 hours, redwood 72, and white oak up to 5 days. Everything is automated, yet the engineers still walk the floor, checking, listening, ensuring every run is safe and precise. When the kiln doors finally open, the dry lumber emerges, bright, light, and golden, like honey. From here, it's ready to be packed and shipped to markets around the world. Beyond just boards, the sawn timber industry is also transforming to embrace a new philosophy: zero waste. Advanced production facilities, such as Columns Lumber, are pioneering the reuse and creative transformation of all surplus products, turning waste into valuable resources, thereby minimizing environmental impact. Large wood scraps are ground into wood chips, which are sent to paper mills or plywood factories. Fine sawdust is compressed into biomass wood pellets, a clean fuel source for the mill's own boilers, completely replacing fossil fuels. And the bark, once considered trash, is now ground and dried into mulch, a ground cover material that helps retain moisture and protect crops. Thanks to this, the mill generates virtually no organic waste. Biomass energy from the waste itself, supplies heat for the kilns. The kilns dry the dry wood creates new waste products, and the cycle continues to repeat. A self-sustaining system, efficient, economical, and astonishingly environmentally friendly. As the sun sets, warm vapors from the drying area still linger and rise, blending with the last light of the day. In that moment, Collins lumber no longer resembles a factory, but a living organism breathing, inhaling the forest, exhaling sustainability. From anonymous round logs in the deep woods to perfect industry-standard boards, that journey takes less than a day, yet it encapsulates a century of experience, discipline, and operational philosophy. At Collins Lumber, every board that leaves the line is not just a commercial product, but a testament to the balance between humanity and nature, where technology does not conquer but nurtures and inherits. And as we look back on this journey, from the forest to the mill, from sawing to packaging, we see a simple yet profound truth. Every value of sustainability begins with respect. Respect for the forest, so the forest can be reborn. Respect for the craft, so the skills can be preserved. Respect for the material, so nothing is wasted. Respect for time, so the product doesn't just exist, but lives alongside humans. A wooden board might lie silent in a house wall for hundreds of years, enduring wind, rain, and the forgetfulness of time. But if we look closely, it is still telling a story. The story of the forest, of human hands, of the steady rhythm of the saw, and of the aspiration to extend the life of the natural world. The forest, the primal source of life, is now extended in the form of the city, in roofs, staircases, or window frames. But wherever it is, the breath of the forest remains, hidden in the scent of resin, in the wood grain, in the hand that touches the product. The mill does not kill nature. It translates that living energy into a new form, orderly, functional, and with a soul. And perhaps that is the greatest message these boards wish to convey. That technology is not the adversary of nature, but the tool that helps humanity understand and preserve it more deeply. As night falls over the industrial park, the mill lights remain on, the machinery hums steadily, and bundles of lumber continue to leave the line, heading out into the world. In each consignment, there is the scent of pine resin, the trace of the craftsman's hand, and the whispered voice of the distant forests. This is not just the end of a production process, but an eternal cycle of life and creation, where wood, technology, and humanity together continue to write the long, endless story of matter and intelligence in the future. To understand the timber industry, we must start in the forest, the home of the super pine, a species that symbolizes the American spirit. In the 19th century, Mississippi, Alabama, and Georgia were once three of the world's largest lumber centers. But after that, the forests were cut down so quickly that within a few decades, many once lush areas became barren.
Right on.
But Americans did not accept the loss of their forests. Instead of letting nature regenerate on its own, they sought to regenerate it faster, better, and stronger. By identifying genes, wood density, and disease resistance, scientists created true athletes of the forest world. The superpine, loblolly pine, grows up to 40% faster than its ancestors. Instead of waiting 50 or 60 years, these trees can be harvested after just 25 to 30 years, less than half a human lifetime. Maximum growth, optimal disease resistance. It is proof that humanity not only exploits resources, but also uses science to multiply its abundance, ensuring this forest legacy will thrive forever. The superpine has completed one growth cycle, but its journey is just beginning. Now, these giant logs will be transported to the Magnolia Mill, where man and machine will write the next chapter for this precious resource. This mill belongs to the Weyerhaeuser Corporation, founded in 1900 by Frederick Weyerhaeuser, who was once called the Timber King by the press. This is more than just a mill. It is a technological fortress. It is the convergence point of traditional craft and the most sophisticated technology. This facility alone processes enough wood for approximately 40 new homes every day, equivalent to about 200,000 board feet of lumber. This level of capacity and precision completely surpasses any sawyer of the past. The new life of the timber begins at the log yard. Massive southern pine logs, up to 40 feet long and 24 inches in diameter, are stacked in piles. They are not just piled randomly. Today, GPS guidance equipment and scanning technology help sort them by species and size, ensuring that each log enters its most optimal processing path. The real marvel begins when these logs meet the mill's primary analysis system. The enormous machines roar to life. The twin-band head rig slices through the 24-inch thick logs like a hot knife through butter. Each saw blade is 12 feet long, spinning at a speed that the human eye cannot fully perceive. But to achieve this speed and reliability, the technology has undergone 150 years of arduous engineering evolution. In 1808, an Englishman named William Newberry conceived of the idea for a bandsaw, a blade moving around two flywheels. At the time, the idea was deemed too dangerous and impractical due to maintenance difficulties and frequent breakage. However, nearly 40 years later, Anne Pauline Crépin proved the opposite. When manufactured with refined steel, the bandsaw was not only safe, but also many times more efficient. From there, this technology spread across North American sawmills. Each generation of engineers added a piece to the puzzle, improving blade tension, optimizing flywheels, reducing vibration, and increasing speed. Today at Magnolia, that legacy has reached a state of near perfection. Each log passing through the system is analyzed and cut individually, as if an invisible craftsman were executing every saw cut. This is a testament to the precision of technology in the new age. After leaving the twin band head rig, the cants are transferred straight to the gang saw area. The gang saw operates on a simple principle: one cut, multiple products. Instead of having to saw individual boards one by one, this system simultaneously cuts multiple boards from a single piece of wood, increasing productivity tenfold. A laser scanning system monitors the cut surface, sending data to the central software. There, an algorithm compares the actual board dimensions with the cutting pattern, calculates the deviation, and then automatically fine-tunes the speed of the next saw blade. After leaving the gang saw, the cants have taken a standard shape. However, the edges are still rough and coarse. To turn them into industry-standard products, a final refinement step is needed: edging. Its job is to remove excess edges, creating parallel faces. At speeds exceeding 1,000 feet per minute, a deviation of even a fraction of a millimeter can lead to the entire board being rejected. Therefore, the entire system must be controlled by optical positioning sensors to ensure the saw blades always follow the precise, pre-calculated path. No two boards are exactly alike, and this is where the intelligence of technology truly shines. Sophisticated optical grading systems scan and classify each individual board, analyzing the grain, knots, and structural characteristics to determine its final use: structural lumber for house framing or appearance grade boards for interior trim. More importantly, Magnolia permits nothing to be wasted. In the recycling area, materials are divided into three main streams. Large wood chips are sold to paper mills, where they are pulped and turned into printing paper, cardboard, or recycled paper products. Fine sawdust is compressed into biomass fuel pellets, a clean energy source used for heating and power generation. Bark is processed and used as landscape material, ground cover for gardens, parks, and even children's playgrounds. This is the spirit Americans call waste nothing, want nothing. Magnolia operates as a self-contained machine. Trees grow from the earth, pass through the mill, and return to life in many different forms. That circle is unbroken because everyone in the line understands that. A seed of wood today is the shade of tomorrow. The entire system functions as a closed-loop circulatory network where every byproduct has value. This is what helps Magnolia achieve a wood utilization efficiency of nearly 100%, a number once considered impossible in the lumber industry. Now we move to the stage that determines the future quality of the board, drying. Small stickers are stacked between the layers of wood to ensure uniform air circulation. The entire pile of lumber is then moved into an industrial kiln drying oven, where the moisture content is reduced to the standard level of 10 to 15%. This process allows the wood to achieve the necessary structural stability and durability before being put into production. Leaving the kiln, the wood advances into the planer mill. High-speed blades will plane all four sides smooth, resulting in a sleek surface and precise dimensions, transforming the raw material into a finished commercial product. After passing through the most rigorous stages of technology, the boards are ready for the final step, packaging and shipping. Each board is stacked automatically by a robotic coordination system. When a bundle of lumber reaches the required count, an automatic steel strapping machine tightens around it, securing the block of wood into a sturdy unit. The strap is clearly printed with the batch number, production date, wood grade, and shipping destination. This data is simultaneously stored in the central management system, allowing for the traceability of every bundle from the forest where it was harvested to the kiln and saw lines that processed it. The lumber bundles are now ready to be loaded onto trucks, much like a well-disciplined army before deployment. From here, the journey of the forest wood concludes within the mill, and a new journey begins in human life. Next, we turn to the story of the American Northwest, the land of mountains, glaciers, and the renowned Douglas fir forests. Here, A new chapter in the U.S. lumber industry has been written. Engineered lumber. If Magnolia represents the power of traditional sawmilling, then Boise Cascade is the image of innovation, where wood is no longer cut from a tree trunk, but is designed, restructured, and transformed into the material of the 21st century. This story begins after World War II, when the world needed lighter, stronger materials to build faster. Aeronautical and construction engineers realized strength comes not just from the material itself, but from how the material is organized. And that very thinking gave birth to an invention that changed the construction industry, the I-joist. From the shape of industrial steel beams, a wooden version was created. Two load-bearing flanges on the top and bottom, connected by a thin but strong web made from OSB, oriented strand board. It is half the weight of conventional lumber, yet offers 50% greater strength. The I-joist ushered in a new era, where wood could reach greater spans in large structures while simultaneously conserving forest resources. This is a testament to the extraordinary adaptability of American industry, especially the company Boise Cascade, in turning natural limitations into technical advantages. Now, let's move on to the most fascinating part: how an I-joist is made. One, drying. The journey begins in the veneer drying area, where paper-thin wood sheets are sent into a massive recirculating heat chamber. Inside, hot air at 200 degrees Celsius blows through narrow vents, removing moisture layer by layer. When the veneer exits, its surface is smooth, dry, and has only about 6% moisture, perfect for bonding with phenol glue. Two, flange production. The dried veneers are sent to the layup and pressing section, where they are turned into LVL, the flanges that form the top and bottom of the I-joist, and the parts that bear the most load. Each veneer layer is coated with phenol formaldehyde resin and stacked with alternating grain directions. On the conveyor, the layers form a massive sandwich, dozens of sheets thick. Once the stack is ready, it's moved into a hot press where the temperature reaches 170 degrees C. The glue melts, penetrating each wood fiber and bonding everything into a single solid block. Afterward, the LVL planks go through a grooving machine to create slots that perfectly fit the OSB web. Three, web production. Next comes the web of the I-joist. Thousands of long wood strands are oriented parallel to each other, mixed with resin, and compressed into large flat sheets. OSB provides excellent shear strength, a stable surface, and lightweight workability. It's the perfect layer to connect the two LVL flanges. 4. Assembly. Finally, both components come together. The LVL flanges are aligned in parallel, the OSB sheet slides in between, and the entire assembly passes through the radio frequency bonding system, a process that uses electromagnetic waves for adhesion. At this stage, high-frequency energy passes through the glue, causing the molecules to vibrate and generate heat from within, curing the adhesive in just a few minutes. 5. Cutting and final inspection. Once the beam exits the press, it's cut precisely to standard lengths, 8, 12, or 16 meters, depending on project requirements. Each finished joist is then scanned with ultrasonic sensors to detect hidden defects within the glue line or veneer. Those that meet quality standards are printed with a tracking code, coated with moisture protection, and stacked on pallets, ready to ship to construction sites across North America. Each I-joist is the culmination of multiple levels of engineering, from forest biology, adhesive chemistry, radio wave physics, to production automation. Above all, it demonstrates the mindset of restructuring natural materials to serve modern needs, lighter, stronger, and more resource efficient. At Boise Cascade, they often say, "Wood is good enough. Our job is to make it smarter." That statement encapsulates the spirit of the entire mill, where humanity no longer just exploits nature, but engages in a dialogue with nature through the language of engineering. Leaving the United States, the journey of wood continues across the Atlantic to southern Germany, the headquarters of Moeringer and Lagenbau. Following World War II with the country in ruins, the Germans chose the path of revival through quality. They could not manufacture cheaper, but they could manufacture better. From that philosophy, German quality became a source of national pride, and Moeringer is a direct product of that spirit, a business that has transformed woodworking machinery into an art of precision engineering. After just 20 years, Moeringer had become a symbol of fine European wood engineering, exporting machinery to Sweden, Canada, and the US. One, laser scanning. The first technology that defined Moeringer's name was the multi-layer laser scanning system. The log is fed into a scanning chamber, where dozens of laser beams shine across its surface, creating a 3D model accurate down to the millimeter. This technology is similar to the CT scan system in medicine, but instead of reading the human body, it reads the body of the wood. Two, cutting. Next is the combined system for parallel cutting and edging. Here, instead of moving through multiple saw stations, the entire process is unified. The log is rotated, positioned, and cut into multiple faces in a single pass. This technology not only reduces processing time, but also maintains absolute parallelism between the edges, a key factor determining the final product quality. Thanks to these improvements, production lines using Moeringer technology achieve an average error rate of under 0.1%, a number that was once almost unimaginable in the wood processing industry. But what they are most proud of is not the precision, but the repeatability. Every shift, every day, every year, the results are always the same. Moeringer's technology has transformed machinery from mere tools into partners for the craftsman, able to see, understand, and make decisions like a true master. In this world, the boundary between mechanics and knowledge fades. Only the art of precision remains. In the final stage, each board continues to move to the end trimming area. Here, a series of high-speed circular saw blades are arranged horizontally. Laser sensors scan each board, measure its length, and then issue the cutting command at a predetermined position. Afterward, the automatic sorting system, using pneumatics and paddles, directs each board into its appropriate group. When the final standardized boards are stacked, we can see a neat warehouse, where hundreds of thousands of boards are normalized, each one carrying its own unique identification code, traceable by its origin, dimension, and quality. That is the epitome of modern manufacturing, not just creating products, but also managing all their data, from the forest to the mill. And so, our journey concludes. From the monumental mills like Weyerhaeuser's Magnolia, to the Boise Cascade plant, where humans no longer just saw wood, but redesign it, and finally to Moringer in distant Germany, where precision is elevated into a life philosophy. 3 locations, 3 approaches, but a single common thread: the evolution of the timber trade, from manual labor to machine intelligence, from instinct to science, from natural material to a technically reborn material. All 3 form a panoramic picture, the path of evolution for the 21st century wood industry, where every saw cut, every board, every algorithm extends the enduring relationship between humanity and the forest. Wood has never been merely a material. It is a memory of time, a witness to labor, the foundation of civilization. Each annual ring tells a year of sun and rain, and every wood product tells a chapter of human history. From the first small cabin in the Wild West, to the modern high-rises soaring above major cities. Today, as the world moves towards sustainable development, wood once again stands at the center. Not only because it is a renewable material, but because it symbolizes the balance between nature and technology. 2 elements humanity is striving to reconcile, and it is companies like Weyerhaeuser, Boise Cascade, and Moringer that are proving it is possible. We can manufacture, build, and develop without losing our bond with the forest. As we leave those mills, the roar of the saw fades, leaving only the rustle of the wind through the pine canopy. A cycle closes: forest, human, machine, and back to the forest. In that cycle, we see the deepest legacy the American wood industry leaves the world: a legacy of respect. Respect for the material, respect for the labor, and respect for the life within every wood fiber. Because wood is not only something humans create, but something that helps humans remember where they came from nature, and will forever be connected to nature, no matter how many new technological eras the world enters. Thank you for listening to the end of the story. If you also enjoy similar videos, please hit the like button, share, and subscribe to the channel so you don't miss any fascinating stories to come. Rawmachines says goodbye, and see you next time. Welcome to Rawmachines, a journey to discover the most impressive processes around the world. In today's episode, we will follow the marvelous rebirth journey of wood, from the deep forest to the mill, from raw material to the finished product. Our destination is Kiln's Lumber Products, a legendary sawmill in the southern United States, where technology and nature harmonize in every movement. Let's begin.